As we have learned in the concept of congruency that two shapes or two geometrical figures are said to be congruent if they are identical in shape and identical in size, meaning these are the two qualifying conditions for two geometrical figures to be identical or congruent, in other words, correct? But what if I get rid of the condition size? Okay, I say that two geometrical figures are only identical in shape but not in size, then such geometrical figures are said to be similar shapes, okay? And that's exactly what we are going to explain through this diagram. I have this triangle A, B, and C. It has included angles as 40 degree, 50 degree, and 90 degree, okay? And we also know that the shape of a triangle is determined by the angles, okay? So angles, they define the shape, right? And the measure of side or the measure of arms defines the size of a triangle, correct? Because if these arms are bigger, you will have a bigger triangle. If these arms are smaller, you will have a smaller triangle, correct? So it is the measure of side length. It defines the size of a geometrical figure, correct? Or a triangle in this case. So what I'm going to do is I'm going to create an identical image of triangle A, B, and C. So we have now a replica of ABC. Okay. Now these two shapes, as of now, these two shapes are identical. Okay. Because they are of the exact same measure in angle and exact same measure in side length. Because I simply copy pasted, correct? Now let me do this. Let me take the second shape and reduce the size of that. Okay. And I'm reducing the size to such an extent that it gets compressed from all sides. Okay, so let us put some labels on these things to better understand. So this is my triangle 1 and compressed triangle is triangle 2. Okay, the original triangle ABC had the dimension of, let's say, 5 centimeter, 4 centimeter, and 3 centimeter. And each one of those corresponding sides, the same side AB, now after compression this becomes 2 centimeter, for example. Okay, and this becomes 3 centimeter becomes 1.5 centimeter, assuming the ratio holds, right? And 5 centimeter becomes 2.5 centimeter, meaning each side is compressed to exactly its half, correct? Now in this case, I will say that these two shapes will be considered similar. Similar because the corresponding angles are identical, correct? And hence we will define that to be similar. But sometimes you are not given the angles, okay? You are only given the dimensions. And in that case, what we do is we find the corresponding ratio of the sides, such as I will find the ratio of side AB, and let's say this is now A prime and B prime and C prime, to make some differentiation between these two triangles. The ratio of AB to A prime and B prime, if it is same as the ratio of BC to B prime and C prime, and if it is also same as the ratio of AC to A prime and C prime, then also we can say that the two triangles will be similar. This ratio actually tells us that how large or how small we are compressing one shape to the another shape, okay? In this case, as you see, 4 divided by 2, in this case the ratio was 4 over 2, which is 2, and 5 over 2.5, which is right here. And BC over B prime C prime is actually 3 over 1.5. 3 over 1.5. Because we know that we compressed it to exactly half, so the ratio must maintain between two corresponding sides. And that is the only thing you need to check for while checking the similarity of triangles. So just to recap, similarity of triangles is identified when they are identical in shape but not necessarily identical in size. Now let us go work on a sample problem to understand this concept a little deeper. Let us take a look at this problem in which we are given two triangles G, I, and H, and then triangle QRS. We need to explain whether these two triangles are similar or not. Okay, but the hidden question is also this: how do I know that side GI corresponds to which side in triangle QRS? Is it corresponding to side QS or to side QR? It's hard to tell from here, okay? So we'll rather do it this way. Let's look at the side GI. Okay, side GI is the shortest among three dimensions of this triangle, correct? That means I'm looking at the shortest distance in triangle QRS, and that happens to be side QS. So I'll put the side QS measurement here, and then I'll compare HG. Diagonal HG is a dimension that is highest among these three, correct? So I'll look for the highest dimension in QRS, and it seems to be QR. So we'll compare HG with QR. That means we'll find the ratio of these two sides. And third remains only IH, which goes with the dimension RS. So let's see what this ratio tells us. GI is 1 and QS is 1, correct? HG is 3 and QR is 9. And IH is 2 and RS is 4. So we see that this ratio is equal to 1 over 3, this ratio is equal to 1 over 2, and this ratio is 1. Meaning none of these ratios are equivalent to each other, correct? And if we wanted these two triangles to be similar, we wanted all of these ratio had to be equal. But since they are not equal, we will say that these triangles are not similar. Alright? So that is how you find. So with that, we will stop here, and I'll encourage you guys to practice on the quiz module.